Today I'm going to cover the recursion and financial modeling section of the 2026 NHT paper. Question 5. Timmy takes out a reducing balance loan with interest compounding monthly. He intends to fully repay the loan. Now when it comes to fully repay the loan, future value is 0 with monthly repayments. And so the recurrence rule is given to you here. What amount does Timmy repay each month? So when it comes to reducing balance loan, the rule is V0 is equal to whatever loan you take, Vn plus 1 is equal to the interest on the loan current value minus the repayments that you make. So this value is your repayment. So please be mindful, some students write it with a minus sign. Don't do that. The answer is 4,215.93. Show using recursive calculations that the balance of the loan after 1 month is this value. So you can see that this whole transaction is happening month to month. So if it's to show a calculation after 1 month, the formula that you basically will use is the one that I have shown you here, this part. So Vn plus 1, that is B1, is equal to 1.0048 given in the recurrence rule times the current value, because the initial deposit was 600,000 minus the repayment that he made. And that answer is what's given to you. Now, if for any reason you got more decimal places in your answer on your calculator, you are to write it first and then write the answer as they want. Okay, so please don't just round it off looking at it on your calculator to the value that you have to show. So if it is a decimal answer that's slightly different from what's been given to you, you have to write the calculator value and then round it off to show the answer that you're supposed to get. Okay, now part C, calculate the annual compound. Now it's also important, to actually see all the parts that I've highlighted, all the important words, and that should stand out so that you're mindful of these concepts all the time while working on the question. Okay, so calculate the annual compound interest rate. As a percentage of this loan. So they've given you the R value, okay, the capital R value. Now we know that R is equal to 1 plus R over 1200, and they are wanting this annual compound interest rate percent. Now the calculation that gets the mark is this one. So it's just basic algebra. 1.0048 take away 1 times 1200, which is 5.76. Now part D, the final repayment. The final repayment questions are always tricky, and that is the question that sets students apart. The final repayment required by Timmy to fully repay the loan is slightly different. Now wherever I see fully repay, I think of the future value being 0. Determine this final repayment, round to the nearest dollar. Now there are different ways of going about this question. I have shown you both ways. Now first, because we have no idea how long this loan is going to go for before we find what the final payment is going to be, the first thing is you first find the repayment period. And in order to do that, we have I, which we calculated to be 5.76, PV to be 600,000. Now what you have to remember is the PV here is plus, because he's got a loan, money has come to him. The payments that he is making should be minus, the future value should be 0, and PYCY, it's a monthly transaction, should be 12, and we calculate N to be 239 point all these decimal places. Now if you show a calculation, you actually have to write these decimal places. Now what does this answer actually tell you? It talks about 239 full payments and a smaller payment which is slightly different. That's at 0.9996896. It's not one full payment. which means it's got to be less than 4215.93. Now there are two methods that you can do after this. You just have to decide which one you find easier. Method 1 is to go up to 240, okay, and keep all the other values the same. Now if you've gone up, clearly the future value means you've overpaid by a certain amount, okay. So it will give you a plus value, future value of 1.30, so $1.30 or 31 cents. Please copy down all the decimal places that you see. Now because you've overpaid, okay, by going up to 240, you should subtract that from the regular payment, which is 4215.93. Subtract all the decimal places. Don't keep rounding off as you go along, because it's only the final answer that you round off. And that gives you an answer 4215. Okay, so that's going to be your final payment. Now the second method is if you go down, if you go to 239 full payments, then you will get a future value on which you have to calculate interest. Okay, interest is to be calculated. Now we know that the next value, Vn plus 1, is R times Vn. Now R here is 1.0048, and this is the balance at the end of, I don't know whether I've shown you, but you have to calculate the balance at the end of 239 payments. And, oh, I have actually, it's here. And then the 240th value will be 4214.623, which, when rounded off to the nearest dollar, as the question asks, is the same as we got in the previous method, 4215. So that's a lot of calculation for 1 mark, but it seems to be a question that often repeats. So as far as reducing balance loans are concerned, you have to maybe keep this in your bound reference. It works differently from annuity situations, and but they are pretty standard questions that repeat themselves over time. So now let's look at the next question. Timmy's car was valued at 60,000 when new. The value depreciates by 35 cents. So obviously this is a unit cost depreciation for each kilometer traveled. Assume he travels 25,000 per year. What is his value after 2 years? So this is a depreciation, yearly depreciation. After 2 years is its initial value of 60,000. Be careful with the zeros, please. Minus the total depreciation in 2 years. So that's 2. And the depreciation is 35 cents for every kilometer traveled, and in 2 years that's your depreciation, 2 times the total depreciation per year. So this is a 1 year depreciation, okay, and so for 2 years that's the value, and then you calculate it to be the value after 2 years is $42,500. The value of the car after n years Vn can be modeled according to a recurrence relation. So you know the recurrence relation has a starting value and a rule. So starting value, it started off with 60,000. Now the value at the end of 1 year is equal to the current value minus the total depreciation per year. Okay, total depreciation per year, which is 35 cents into 25,000 kilometers per year, which is 8,750. And that is your recurrence rule. The value of the car after traveling n kilometers, Wn can be modeled by a rule. So this is a value after n years. So please be careful. If they say write it in terms of Wn, you have to write it in terms of Wn. Is V0, its initial value, minus the depreciation per kilometer traveled, okay, because it says after traveling n kilometers. A lot of students wrote 8750 times n. So it's per kilometer, and so that's your total depreciation, and that's your answer. This is how you usually know it, but you have to write it in terms of the alphabets that they've given you. The next question, question 7, gives you an amortization table, which is a further reducing balance loan compounding annually, and he makes annual repayments. Now, after 1 year, Timmy changes to an interest-only loan. Now, the interest-only loan implies that your value that you have will stay the same value, because all you do is make repayments equal to the interest. So what you should know is that these two blanks will ultimately work out to be the same. And because you're doing that, if these two are equal, then the principal reduction will be 0 and the balance will remain the same. So even before you start working on the question, you can fill up these two. So all you have to do is calculate the interest. Now, in order to calculate the interest, we have no idea because this question has not mentioned it in the previous part of the question. And so in order to calculate interest, you can just say interest over the previous balance times 100, and that works out to be 4.85%. So now using 4.85%, we can calculate the interest on this amount, the previous balance, which is 4.85% of B1, the balance at the end of the first year, and that works out to be 12,222.56, and that takes this place. Which is also equal to the payment that you make. So now we filled up all the blanks given, and that was your question. Question 8. Now they move on to an annuity investment. So what's interesting about this paper is they have covered almost every kind of question in this particular paper, and would be a really good revision paper. Timmy makes an annuity investment. The value of the annuity AN after N monthly payments. So here the monthly payments are not payments made by him but to him. Okay, so that is the idea, because he's investing money to get some regular payments till the value of his investment becomes 0. Now the recurrence rule explaining this particular question is given to you. How many years is Timmy expected to receive a monthly payment? Now this can be done in 2 ways. One of them is by the financial solver. That's this way. How many? So N is the question. Now I has to be calculated. 3%. We don't know, but we can calculate it from this value. So we know that if you've practiced enough, that this value is 1 plus R over. Now it's going on a monthly payment, so it's 1200 is equal to 1.0025, and therefore R can be calculated as 0.0025 times 1200 is equal to 3%. So we now substitute that 3% into the financial solver, and because he made an annuity investment, it has to be negative. Money leaves him. He puts money into the bank, so PV has to be minus 225,000. Now the payments that are made to him, so because it's made to him, should be positive, and it's 1,862.53. Now these payments go on for N payments, which we don't know, till the future value becomes 0. Okay, so these are concepts that you have to know. Now PYCY is 12 because it's monthly payments. So when we tap on N, we get 143.9990744, approximately 144 payments. Now the other way of doing it is a sequence tab, where I put the recurrence rule that's been given to me exactly as I see it. And the only problem is because I don't know how long N can take, I just put start and end as 300. Now if that doesn't work, Now, what's the idea? The future value has to become 0, okay? FB should be equal to 0. So I put 300 just to check when the positive values as they go down become negative. And I found 143rd payment. After the 143rd payment, the balance was 1,856.17. And after the 144th payment, it became negative, okay? So it's definitely not 143 because there's still a balance of 1,856.17. So it must be 144 payments, and that is your answer. So these are two different ways of looking at it. Students find different ways of thinking, so you just adopt the way you want. Now the next question is a very interesting question and a difficult one for a lot of students. Determine the total interest earned in the first year of the annuity. Now, in order to find the interest on the first year of the annuity, you have to check out how much of the actual deposit has gone down by subtracting the future value from the balance, okay? So your deposit minus the amount left in the bank at the end of 12 months is the amount on which you have gained interest. So the first thing you have to do is calculate what is your future value at the end of 12 months. And so in order to do that, you put n is equal to 12, I is equal to 3, which we know from the previous question. Now PV is minus because he deposited that money. He's been getting money, so that's plus. And the future value, which we don't know at the end of 12 months, is calculated. PYCY is 12. Now, this is the money on which he gained interest, the difference between these two, okay? The deposit minus the future value. Now, how do you calculate that interest? So, the total number of repayments minus deposit minus future value is actually the interest. So, the total number of repayments that he got also included the interest, okay, for that 1 year. So, 1,862.53 times 12. Take away this answer to this calculation will give me this answer, 6,533.6979 approximately. It's always important to write your calculator answer first and round it off to the nearest cent, is because that's your question. And even otherwise, if it's not mentioned, you will always round off to the nearest cent unless asked otherwise, okay? And that is the total interest. It's very important to actually take this down in a summary, because this is a frequently asked question and a question that students often make mistakes on. Part B, Timmy's friend Jane invests a principal amount in an annuity that provides a quarterly payment, that means 4, of 7,600 for 10 years. So the total period of time for which this question is applicable is 40 payments, quarterly payments. This annuity has an interest of 3.2 compounding quarterly, and the value of the annuity Vn after n quarters can be described using a recurrence relation. Now the recurrence relation consists of two parts, a starting value and the rule, and from what we see in the question, we really don't know how much he deposited, so that should be the very first step. So in order to calculate V naught, we know that it's for 40 payments n. We also know that I is 3.2 from what's given. Now we don't know how much has been deposited, V naught, which is PV. PMT is 7,600 because it provides a quarterly payment, which means Jane gets the money, and because she gets the money, it's a plus till the future value becomes 0, and PYCY is 4, and that gives you your V naught to be this value. Now it's important that you see it's a minus because Jane is making the investment, so money is leaving her, okay? So we have V naught now. Now be extremely careful to write it with a positive sign, okay? Don't write any sign, just don't write it negative. So the next step is now to calculate the R value, because we know that the recurrence rule will be that. Now it's 3.2% per annum, and so 1 plus r is 1 plus 3.2 over 400, and that gives you 1.008. And so now this is your D value, which has been already given to you as regular payments made to Jane, and that is your D. That was an interesting question because it actually requires a few calculations. You just have to have great clarity in thinking, and I hope you enjoyed listening to this paper being explained. Keep practicing. It's always good to attempt a paper first before looking for the solutions and not looking at the explanation straight away, because that way you'll actually know what's happening. In case you have actually just looked at this explanation, it would be good to shut it down and attempt the paper afresh, and then look back to see if you've got it correct. Thank you. Bye.